Hello everybody, welcome back. This is our final installment of the test review. Alright, so the first problem here, they're asking us to give a correct answer for each proof. So number 20 says, for proof number 1, what is the reason that these triangles are congruent, AEF, and DEC? Well, if you look at the given information here, they told me that angle A here, and angle D were congruent. They also told us that E is the midpoint of AD, so that guy right there would be congruent to itself by definition of midpoint. And then finally, I know that vertical angles, this angle here, is congruent to that angle there. So these two triangles are congruent by angle side angle. Okay, for proof number 2, they're asking us what statement would have the reason of definition of bisector. So if you look here, I look for the words bisects, and I see that XY bisects the angle MXZ. So the angle MXZ is cut in half by definition of bisect of XY. So what I would write would be two angles here, and one angle would be angle MXY. This would be the statement that I would write to the reason definition of bisector, and it would be angle ZXY. All right, so that's that one. And then for the proof, what is the reason that MY is congruent to MY? Well, we would have to go through knowing that this angle was congruent to that angle, and we know that this side is congruent to itself, and that XZ and ZX are congruent. Then we would have this triangle is congruent by side angle side, and then once the triangles are congruent, we can use the corresponding parts of congruent triangles are congruent, or CPCTC, to prove that MY and YZ are congruent to one another. All right, these next two are having us write a proof, and so the first thing that we always do in proofs, put the vertical there, is we write down our statements and reasons. Sorry, I can't write all of a sudden. So first thing I write down is my given, and when they write two vertical lines, that means they are parallel. So PS is parallel to RT, so that's why the little arrows are on there. That's a given statement. And then we also know that PQ is congruent to TQ, the segments. So those were our two given statements. And so TQ, and they marked them for me already. And so with this, knowing that they're parallel, we could, all right, so we have a couple different options here. We could say angle SPQ is congruent to angle TRQ, which, oops, I said that wrong, not TRQ. That would be RTQ. RTQ. And so SPQ would be this angle here, and RTQ would be that angle there. And that would be the reason, remember we talked about this earlier, the N or the Z shape, and when we have parallel lines, that makes those guys alternate interior angles. Now, this is not the only pair of angles that are congruent by alternate interior angles. You could prove S and R congruent, and then if I said S and R by alternate interior angles, then this would be angle side from our reason. Or the other option is, which probably most people saw, is that angle PQS is congruent to angle would be TQR, and those would be vertical angles. All right. And so with either one of these guys, this one by getting vertical angles, now this is my reason that these triangles become congruent is different. It's not angle side, it's actually angle side angle because the side is between the angles. So there's a little variance of why we can prove these triangles congruent, and it's kind of left up to you how you see it. So if you saw it as angle side, that would be okay. If you saw it as angle side angle, that would also be okay for this one. And so how this would change the proof, and I'll write it in a different color, is that for step 3, or for step 4, we could have said for our reason that angle S is congruent to angle R, and then step 5, the reason would have been, that would have been the same reason as vertical angles. This would have been the statement. I just don't have room to write it over there. And then my reason would have been angle side. And this isn't the only way you could have done it. You could have used the vertical angles in that and the S and the R angle by parallel line, alternate interiors as well, and you'd still get that. You'd still get that information. So then over here, on this proof, we're going to do the same thing. We're going to write our statements and reasons. I'm having trouble with straight lines today. Anywho, first thing I'm going to do is write down what they gave me. BD bisects AE. That's given. Step 2, angle A is congruent to angle E, also given. All right, and they marked those for me. So I'm going to use the information that they told me in step 1 for my next one, that BD bisects AD. So this line BD cuts AE in half. So what I know is that this piece is congruent to that piece. So I know that AC is congruent to CE, not by midpoint, but by segment bisector. Definition of segment bisector. And so now that I know those and I have those angles, well, I can say step 4, that angle, I'm going to use vertical angles here, ACB is congruent to angle ECD, and that would be vertical angles again. And then step 5, once I've got the vertical angles congruent to one another, now I have enough information for angle side angle to prove that triangle ABC is congruent to triangle EDC. And if I make that line like that, we can call it for angle side angle. Right? And that's how we're going to go through the proofs. You guys, for your proofs, are probably going to be just filling in some blanks, but this is how you'd write a full-blown proof for that one. All right, now we're going to talk about our reflections and all of that fun stuff, and we're transforming stuff. So we're going to start by taking the point 6, -3. This point right here, this will be our base point there, and we're going to reflect it across the line y equals -2. So y equals -2 is a line, and I'll draw on a green line for y equals -2. So if I reflect it across that line, where's it going to end up? Well, it's going to end up right there. So that point looks like it is at 6, -1. All right, and so I just drew that line in there. Let's get rid of these guys. Let's actually, hold on, let's leave that there. Let's erase that point. We're going to reflect across the line x equals 4. So I got to take this line, I'm going to move it around here a little bit. Find where x equals 4, make it a vertical line if I can. There's a vertical line, and that looks like x equals 4 right there. So if I reflect it across the line x equals 4, it looks like I'm 2 units away. So it looks like my transformed point would be about right there, 2 units away if I went across that line. So it looks like it's 2 over and 3 down. Okay. So then my next one, I have 2 different transformations to do. So I'm going to, I'll erase out this point right here, and we'll start with, we're reflecting across the line y equals -x. So let's first draw that line. Let's take this guy right here and draw the line y equals -x, if I can grab it. There we go. There's the line y equals -x. And so if I am going to get reflected across this line, I am 3 units this way. And so it would be, it's going to end up at the value of 3 units over and 6 units down, which puts us at this point right here. That's for the reflection across the line, is that it is at 3, -6. Now, if I take that point, 3, -6, and translate it 3 units to the right, be 1, 2, 3, put me at 6 for my x value, 6 for my x value, and then down 4 units. Well, I'm going to subtract 4 from that 6, and I'm going to get negative 10. So it's going to be a point like down here somewhere. All right, so let's get rid of those. And so now we're going to reflect across the line x equals negative 1. So x equals negative 1 is a line that's over here, just like that. So let's start by reflecting this point across x equals negative 1. Well, it looks like I'm 1, 2, 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6, 7 away. It would put me like right here. So that puts me at this point is at negative 8, negative 3. And then if I reflect it across the line, take that pink point there and reflect it across this line, it's y equals x, which would be a line that looks like that. Well, I switch the x and y's places, so it's going to be at negative 3, negative 8. All right, and that's kind of using my rules, negative 3, negative 8, so that puts it like down here somewhere, up there. All right, so then the last 3 here, we are going to be rotating, and so delete that. So now we're going to rotate this guy 180 degrees about the origin, clockwise. Counterclockwise and clockwise, remember, it doesn't really matter. So when we're rotating something 180 degrees, we basically just switch the x and y's places. So to get it 180 degrees, I'm going to go back 6 and up 3, which puts the point right there. So that is the point that we're going to get negative 6 and 3. If I take this point right here and rotate it 90 degrees clockwise, well, remember that was the same as 270 counterclockwise, so that puts us like right here. So when I go 90 degrees, I'm going to switch the x and y's places and change the sign on the old x value. So this guy clockwise was switch the x and y's places, so make this guy y negative x. That would be 90 degrees clockwise. So my ordered pair ends up being at negative 3 and negative 6 down here. That would take me clockwise. So I got to get rid of the other point. I don't think I went down 6. 1, 2, 3, 4, 5. Oops, no, I thought so. It would be right here at 3, negative 6. Negative 3, negative 6. And then if I'm going to go 270 clockwise, counterclockwise around the origin, well, that's going to put me up here in this quadrant up here, and it's basically keeping the x and y, or switching the x and y places and changing the sign on the y value, so it's negative y and x. And we talked about this yesterday, so that would put me at the point 3 and 6. All right, so this concludes the review. Let me know if you have any questions. I will talk to you guys about this tomorrow.